Test, test, test. Alright, it looks like YouTube and Twitch are going, but X is having a bit of a problem. Let's see. Okay. Looks like it's on now. Alright. There we go. Alright, so I got a bit of a late start. I spent a good chunk of this morning and early afternoon writing a post for my website about the virtual memory visualizer that I'm working on. And I also recorded a YouTube video to kind of check in on what I'm doing, what progress I'm making. And I think I'm going to do those somewhat periodically. Obviously, they take some time to do, so maybe like once a week or so after I've had some significant progress. But at the end of that video that I recorded, I was thinking about like what my next steps are, and the primary next step is going to be getting the zoom to be able to focus on wherever your mouse is located at, which requires me to put objects onto some type of coordinate plane that can then be scaled and repositioned, which doesn't seem like it's too difficult, but I've never done anything like this before. So I want to look to see if there's library support in Raylib or one of the related libraries for doing something like that. So yeah, that's what I'm going to be starting on here. So let's jump over to VMViz and let's open up the Raylib docs. And they recommend just doing the cheat sheet here. So one of the things is like when you draw, you have like a draw rectangle. Let's see if there's like a rectangle outside of this stuff. So this is shapes. So it should be in the shapes section. This is collisions. You don't have to worry about that. Check if point is inside of a rectangle. That's pretty easy to do the math yourself. I don't know why you would need to call. I guess maybe just get it into a library. It's easy to implement, but why not just use a library? Might be their thinking there. Circle and rectangle. Okay. And then get shapes texture rect. Get texture source rectangle that is used for shapes drawing. And then get shapes texture. Okay. That's something else. I'm not sure what shape textures are. So we have draw rectangle. You give it position. You give it width, height, and a color. V is just the vectored version of that. Draw rectangle with rect is just a rectangle version of that. And the rectangle object itself, is that defined somewhere? Oh, what is this stuff here? Textures, okay. Text. Models, interesting. Draw cube. Basic geometric 3D shapes drawing functions. Struct rectangle it's just a 4-component type. Something fancy. Anything up here for rectangles? No, it's just core. Alright. And then we have draw rectangle pro. Hey, look at that. There's an origin vector. And a rotation. So I think what we need to do is use the pro version. So you say draw this rectangle relative to this origin, and that origin can then get modified. But the scale of the rectangle cannot be modified. That's interesting. So I think the draw rectangle pro thing is what I'm looking for, because it has an origin, but it won't handle the scale. It'll just handle the repositioning. Let's look for origin. Yeah, origin. With pro parameters. Is rectangle the only thing with origin? No. Draw texture pro. Draw billboard pro? What is that? Draw text pro. So we can get text and rectangles relative to an origin. That's good. But it doesn't seem like that's a texture. Yeah, it seems to be like there's no draw circle pro. If you look here, pro. Alright, well, let's try the pro version of this. So if we go under here to our draw UI, so I'm going to create a global next to the zoom, and we're just going to call it origin. And if I look for origin, it's a vector 2. Yeah. And we'll just initialize that to be 0. I think I can do that, right? Yeah, do that. And then we'll do a handle input where we say left get key pressed. In fact, I can just go to definition on this, right? Oh no, it goes into the header file. How do I go into the source code? We'll just go ray r rayson 5 raylib source raylibc. Our core, this would be under core, right? Get key pressed. Yeah. I wish I had better documents on what keys are pressed. So the key I want to look for here, we'll say default. We're going to print out the key, unknown key press. Key pressed. And then we'll do %C. And in here we'll do key. Oh, and I need to have that within the switch. And we need a break. Okay. Let's do our make and build draw UI. Okay. So if I hold down D, it doesn't do successive. Okay. Let's do left, right, up, down, and then kill. Huh? Okay. Let's also do an exit here. We'll do that. It doesn't say what. We'll put a single tick around %C, and then we'll do also the hex value, 0x %x. I think I can just do that, right? Key. Alright. And if I do it right here, boop, 106. 107. So right is 106, left is 107. Let me just do a man ASCII. Right is 1 to 6 decimal. That doesn't seem. Oh no, it's hex 1 to 6 hex. What? 106 here. No, that's octal hex 106. But there is no 106 hex. Something's messed up there. So we're supposed to be doing hex here. 106 would imply a 2-byte sequence. Not a single byte. I guess it's an integer, so it can be up to 4 bytes. Okay. So it's not an ASCII. Well, I know for a fact that raylib examples use the directional arrows on one of these examples. So input keys, here we go. And we have these constants. Makes sense. Okay. So here we can say, hey, if the case is and I'm just gonna like comment that out. Key right. Sorry, not literal key right. Let's say it like that. If I go to definition here, okay, so these are all the keys here. Interesting. So I can say key Q instead of that, and that'll give me both Q, uppercase Q and lowercase q. Let's do that. That'd be a better thing here. Key Q. And then we'll say up. Sorry. Up. Down. Left. Right. So this is going to change the origin. So up would say, okay, we're going to add like 100 to the up component. So if your origin is here and you want to go up, you just have your origin go down on the y-axis. But because down is positive in graphics, you would have to add, basically. So up is actually going to be an addition. So it would be origin dot y plus equals 100. And then break. Oops, I need a semicolon. And then we'll do something very similar for these. So down will be, of course, the opposite. Left, so if you want to go left of the viewport, you have to shift the origin to the right, which would mean adding. And then if you want to go, just double check here. If I'm hitting key right, I want to shift the origin to the left, which means subtracting. So that is correct. Okay. So that's handling the update of the origin. I just want to draw the origin as like a little box here every frame. I really don't like loading this stuff. So I might just take out this thing and just use the default font for now. And then we'll get around to dealing with font default. There we go. Can I just do that? No. I'd say get font default. Yeah, okay. And that'll avoid the spam in the console. Get font default. There we go. Alright, I want to draw the origin. So this is draw buff. I want to have a separate function called draw origin. And I'll just do it up here. Void draw origin. And I'm going to give it, or have it reach out. So this would be draw rect angle pro. And I'm just going to create a rectangle here using this fancy syntax I learned yesterday, where you can define the struct inline. So this is going to be a rectangle. Well, I guess the first rectangle, I want to say this is going to be like 200, 200, just off from the origin. And we'll give it a 0 rotation. But it's a rectangle, so it has X, Y, and this will do what? Color black. Black. Rotation 0. Origin X, Y, width will be 50. And height is 50, something like that. And then we'll draw the actual origin. We'll make this one red. And this will be the origin. And it's going to be from a vector 2. And this is just going to be 0, 0. Or actually, we can just 0 initialize it like that. And what did I mess up? No, okay. It's complaining here. Vector 2 is incompatible. Origin, what? It is a vector 2. Incompatible with type of rectangle. Oh, because origin is not a rectangle. We'd have to create a rectangle here. And say x is equal to origin x and, oops, sorry, x is dot x. I think just do origin x like this. And then origin dot y. And then maybe like 2020, something like that. All right, let's go ahead and try that out. Oops. Okay, so look at that. So we got our origin and we got our offset from the origin. So now if I hit right, oops. So down and up seem to be working, but I messed up and I forgot to change these to X. I had in my buffer to change this to X, but forgot to flush that buffer. So let's redo that. Zoom out, and then down goes down, up goes up, right goes right, left goes left. So we have directional control now, which is nice. Yeah, it's kind of weird because like I'm going up and the origin's coming down. I'm going right and the origin goes left because it's kind of like I'm panning away from the origin. But what's interesting is that like that box has the opposite effect. Go back here. So that box doesn't follow relative to the origin. It goes inverse to it. Which is kind of interesting. Like, why would it go inverse to it? Maybe they're doing the math already for the panning. So if I go right, I mean, I don't like the behavior of the origin, the pro thing. I wish it was what I imagined it would be. So I would like to look at the definition of this. This would be shapes.c, and this would be draw rect angle pro. So this takes, no, that's a call into the pro, okay, with the origin of 0. Alright, so it takes those, yep. Top left, top right, bottom left, bottom right. Don't know if that's how that works, but okay. Only calculate rotation if needed. So they're doing the rotation here. If support quads draw mode. What is quads draw mode? Huh. Huh. Otherwise, we draw triangles. So I think the only real part here is a subtraction of the origin. So we're subtracting off the origin. The origin vector. So if it's pointing to the right, we'll subtract that off. And we'll go to the left. And because the origin is a point, it'll never have a scale. So we're going to have to scale our objects anyways. I'm wondering if I should like do my own sort of transformation on these values by having them go through a function. So any drawing of rectangles or text would go through a function that I owned. It would apply the transformation instead of relying on half the transformation being done by the library and the other half being done by me. So just have me do all of it. Plus I don't like the way that they're doing their calculation here. So I think that's what I'm going to do. So we got draw a rectangle. So I think what I'll do is I'll go up to the tippity top here and we'll say, hey, draw a rectangle. And let's see. Oh, those are different. It's down here. Go into here. I'm just gonna grab some of these here. Let's see which one I want to do. So RL API is what it's gonna return. No, that's just a pound defined. It's a void. Okay. And then do we want to give XY positions? I don't think so. So let's take in the rect. I like that. And then the origin we won't have to mess with. Rotation, we're not, so it's just going to be the rect in color. And we're going to call into this after we update the rect. Oops. Okay, and here we do rect color. But first, we need to take that rect because it's a copy, and we say rect. We have to apply the zoom, and we have to apply the apply position, translation, and zoom. So down here, the zoom, if you look for zoom here, is being applied directly to these values here. And then at a certain zoom, we don't even draw. This will be a draw text. And we'll just say it's empty for now. But I do want to get around to doing that at some point. So char star here, text. And then we'll take a vector for its position. Yeah, its position and its font size. So position will be a vector 2, and font size will just be a float. I think that's what they did here, right? Oops. Yep. So we'll leave that at being a no op for now. So we got to apply the transformation and zoom. Let's just do translation for now. So it's going to be a so we're moving the origin over to the left. So that means that we should add the values instead of subtracting them. So rec.x is going to be a plus equals to origin.x, and y origin y. So that would be nice, but then we have the zoom factor. So you have to also multiply the origin's position by the zoom. So basically what I'm going to do is I'm going to start by, when I draw the origin, since we're not doing that anymore, let's pull this up to here since we're doing it here. We'll have a translate and a zoom. And down here, I'm going to say, hey, code rename zoom to be zoom, like that. And then we'll have two functions here, translate and zoom, and we'll apply them both like that. So the first one we're going to take, so we don't have to translate the origin. The origin is just going to be where it's at. But this I want to do as like a separate function call. And I'll just do them like that for now. Don't have to translate that. Zoom, and we're going to zoom a vector 2. It's going to return a vector 2. Oops. And here we can say, hey, zoom in origin by, well, I guess it knows how much it's going to zoom by. And that's going to give us the new position. So auto position. And that's going to be pause X and pause Y. Zoom vec. Want to say zoom or do we want to say scale vec? By zoom. Let's call it scale vec. There we go. So say we're going to scale the vector origin. And I also want to scale its rectangle. So I think I actually just return back here. I'll come back to that. So we have scale vec, scale rect. I want to shorten this thing too. We draw rect. Okay. All right. So this is going to take and return a rectangle. Okay. So here we can say rect.x is going to be plus equals origin. Oh, we're just scaling this thing. Do I want it to be two steps? What's a scale and a translate? Relative? Let's say it's a relative vec. And then here we'll do our rectangle. Here, this will be rect. Let's comment that out for now. This will be origin X, origin Y. All right. No origin on that. So draw a rectangle. We just want rec. Like that. There we go. Okay, so we have to do a relative rect. So this will be first translate. No, because we have to scale. Well, what I was going to do is say rect plus equals origin.x, so rect.x. Can I type today? Origin.x, and then rect.y, origin y, and then the width and height, rect.width times equals. So I think we're just multiplying it by the zoom factor. So times equals zoom, and rect.height times equals zoom as well. Okay. So that'll get us somewhere, but not the place that we want to be. I don't think. No, that sounds about right. With the origin specifically, we can do that. You know what? This should be 0. It shouldn't be origin x. It should be 0, 0, 0. And I also want to center this at some point, but we should be passing in the origin positions in there. We say we want this thing to be at 0, 0 relative to the origin with the width and 20. So zoom will change its width and height, and the translation will keep it on the origin because it's basically going to be on the origin. Okay, so that works. Let's go ahead and start that. All right, so you can see here, it is always at the origin. And if I go right and left and up and down, it follows the origin. What is all that text there? Oh, that's just for things that are not drawn right. Okay. All right, so that is working. Let's go back over here. So a relative rect. So that works for the origin, but if I wanted to do one off from the origin, say, and in fact, I'm going to stop drawing the buffer because it's kind of just a bunch of noise at this point because I just want to work on this. Okay, so that worked for the origin. Let's also draw one off from the origin. So this is going to be maybe like 100 pixels off in both X and Y. And we'll make this blue. Okay. So the translation looks like that works perfectly. Now scaling, you see how they just scale in place? The position needs to update along with the scaling. So let's quit out of that. So in here, where is it? So this is wrong. That only works if you're at the origin. So we have to multiply the rect value well, I could say the first thing we need to do is we have to multiply rect xy times the zoom factor. So now when we zoom in, it's scaling it out. But what's going to get messed up now is the translation. No, that looks okay. It looks about right. Why did I think that was going to be wrong? So this is all saying, hey, whatever your position is relative to the origin, scale by zoom, both your XY position and your width and height. Which makes sense because that's like two vectors basically. It's the vector to where your top right, top left position starts. I think it's top left. Might be bottom left. And then your width and height. I think it's your top left, yeah. And then width and height is another vector that has its origin at your top left and goes to your bottom right. And so we're just scaling both of those vectors by zoom. And then we have to add the translation offset. Okay, it seems like that's all you need to do. So if we want to do this against a vector now, we would do something similar. So this is scale, and then this is translate. And we have no rotation. All right. So here, this is going to be vec. We only have one vector. And then we have to translate that vector as well. Okay. So that works for the rectangle and the vect. Let's do a few different ones here. So each one of these is 20 by 20. So can we do like do red, green, oops. And then maybe here we do, so that's a 2020. So we'll do 2020 as a starting point. I want to make sure that they're consistent here. So that'll be 40, 40. Red, green, blue, 60, 60. Oops. Red. We'll do green and a blue. So that's red. Green, blue. This will be 80, 80. And 100, 100. Okay. All right, so that puts them all in order there, and if I zoom in, they should stay in order, touching each other. Looks like it works. Cool, cool, cool. So that's our coordinate plane there. And what I want to do next is zoom based on the mouse position. I think that's probably the next thing to do here. So down here we had this function called update zoom, I think. Yeah, update zoom. So that gives you, it says, hey, get the mouse wheel move. And based on its value, update the zoom. But we also have to update the origin. So that'd be getting the mouse position and updating the origin to zoom into that mouse position. So it's probably going to be like a get mouse position. That looks about right. That gives us back to our vector 2. Or just say auto position. That takes no arguments. Yep. So what we want to do is we want to zoom in. I don't think our zoom value is going to change, but we also want to translate. So say our mouse is in the center of the screen. Say this is the viewport here. And we want to zoom into the mouse. So our zoom has to go in the value that it's currently going. But then we have to translate basically like right now we're zooming into the upper left. So we want to translate to the left and up some degree. So it'd probably be the position, but with a zoom applied to it, I would think. Let's just try it and see what it looks like. It's nice about this, we can just experiment. So I think we're going to do origin.x is going to be equal to some value, and then origin.y. So this is probably going to be a star equals. No, it can't be. It has to be a plus equals. It has to be negative because you have to go to the left hand side. So maybe just stick with a minus equals because you know it's always going to be negative. Well, it's always going to be negative if we're zooming in, but if we're zooming out, it'll be positive. We'll say position.x times, we'll say 0.1. And we'll call this thing the zoom factor. Const zoom factor is equal to 0.1. And that's going to be a const auto. And then it's going to be 1 minus zoom factor. This will be 1 plus zoom factor. And then down here, we're going to say, hey, take your position, and you're going to multiply it times the zoom factor. And do the same thing for y. But it's going to be the same deal here, where if value is less than 0, we do one thing versus the other. So I think what we want to do is just like get both of these values and then branch. So it'll be like this. If it's less than 0, if it's more than 0, we're adding to the zoom factor, which means we have to subtract from the origin. This would be adding. Okay, let's give that a go. Hey, look at that. So I want to zoom out from this, which is send it. Let's zoom in. Let's move to the right. Yeah. Say I want to zoom into the blue. That did not work the way I expected it. I mean, it's kind of working. Not really. It's directionally correct, we'll say that. It's kind of, like I had my mouse over the blue and it's kind of zooming in, but basically the translation effect is not significant enough to account for yeah. Okay. It's directionally correct, but it's not correct. So, what's going on here? Here's the deal. when I zoom into a point, I want everything to zoom around that point, which means we have to know where that point is on the Cartesian plane that's implied. So maybe we do a draw grid here for debugging. So we have our draw origin. We'll do a draw grid. And we'll call this thing code rename. Code rename. Draw origin debug. This is debugging. It's not really helpful for us in the production code. And then we'll have a draw grid debug. So let's do a void here. And draw grid debug. Basically, we need to draw lines. As start position, Y position, start position X. Let's do start line, draw line, strip. Let's do vector. I like this. Draw line V. So the vector is going to have a start position of origin and an end position of origin plus infinity to the right. We'll say what here? Start is equal to origin. And we'll do auto here. End is equal to origin. Start and color will be black. So I just want to go in the positive directions. So what I'm going to do is say origin plus, I can't do plus on vectors because we don't have operator overloading, but we can say n dot x plus 1024. Sorry, plus equals 1024 and n y. Okay, so now we have a start and end. And basically I want to do in addition onto the start dot x plus equals I times 10. And we don't want y because we're going to do an x in this dimension. Okay, so this will be for I, or we'll do size ti is equal to 0, I is less than 80, we'll say. In the x dimension will be 102 I plus plus. Okay. So that will be the X. Are we going in X? So we start at the origin every loop. We add on to X. So these should be drawing horizontal lines. So this wouldn't be 1024, it would be like 768 or whatever. Okay, so these should be drawing horizontal lines. I don't see anything. I see one line. Oh, end is going to be y plus equals that. Okay. There we go. Oh, we have to copy the end value as well. Okay. And x is equal to start x. Actually, no, this should just be start. And we'll do it that way. So yeah, our first point, our start is going to be at the origin. We then mutate it to go 10 pixels to the right for every I in the iteration. And then we move its Y down to the bottom for the end position. Okay, so now we should have horizontal lines that we can scale. I am going to disable the zoom origin stuff because that's broken right now and it's confusing me. Alright, so we have that. And then I also want to give it 7 maybe 10, but this is going to be on the Y, this is going to be on the X. 1024 black. So now we got our grid. It's not being scaled. So let's do that. So instead of draw line V, what we have to do is say draw line, and I want to move this down here. We'll have a draw line here. Draw line, it's gonna take in start vector to end and a color, which is type color or tint. I forget what the name of the color is. No, it's a color. Color. And that's gonna be this, but we're also gonna apply the translation to it. Okay, so it's gonna be now draw line, and it's got to go through relative vec here. So relative vec of start and relative vec of end. Okay. Zoom, zoom, zoom. Okay. Look at that. Isn't that a nice little grid that we got? I mean, it's not infinite. It's finite. Maybe we make it a little bit bigger. It's not too hard. We just gotta set these things to be like 10, 24 times, or we do 1 to the power of like 12 would be 4K, so 14? 1 to the power of 14? Yeah. We'll do that in both directions, why not? 1 to the power of 14. Oh, but we don't have the iterations. We have the length now, but we don't have the iterations. Okay. We'll just go up to the same number here. 14. That's a lot. So, like 1K is 10, so 11 would be 2K, 12 would be 4K, 13 would be 8K, 14 would be 16,000 of these. I don't think we need quite that many. Maybe we stick to maybe like 1K. Because it's multiplied by 10. So the actual pixel width, let's say like 5K is the pixel width. We don't even really need 500. So this could be actually 9. I think we'll be fine. Alright, there we go. And by the time we got it here, it's kind of useless anyways. Okay, so we got this nice little grid here. So everything should be scaling on this grid. So when we zoom, the effect that I want is that the point that I'm pointing at stays still. So we need to use a relative vector. That's one thing we need to do. So up here we get the, sorry, where am I? Yeah, up here we get the position, but we get the position relative to the screen, like what we're looking at. And what we need to have is like, what is that pixel? What point on the grid is it pointing at? Not what pixel it's pointing at on the screen. That's really what we want. Is we have this mouse position. We want a mouse relative position, which is a different concept. So how would we do that? We could apply the relative vec function to it. But that's not what we want. What we want is like an inverse. So the relative vec takes a position on the grid and turns it into a position on the screen. What we want is the inverse. So we'll have a inverse relative vec. So it'd just be every operation inversed, right? I hope. Oop. Okay, so that'll give us inverse, and we have to pull that up. So you need that up here. So update zoom now gets pulled down at least to maybe here. Inverse. I'll just put this in parentheses. Oops. Inverse relative vec. Okay. So now we took our coordinate, just say that worked. which I think it probably did, but I'm not certain. But that took our point in the pixel space and gave us the point in our vector vector plane. So now what we have to do is you have to kind of like orient around that thing. And that's the part I don't know how to do. But what we could do is just do that and see what happens. All right, so I'm gonna hover over the blue. It did not do what I wanted. And oddly enough, like all the freaking grids are freaking out. That is not something I would have expected. I thought we had that locked down. Looks like we don't. So if I hit Control C here and redo it, and I do, yeah, look at that. It's like it's translating too much. The debug lines are messed up. This doesn't seem like it's working anyways. Let's go ahead and comment that out. But I want to fix the debug lines too. Debug grid. All right. So if our start is at 0 and our end is somewhere off in outer space we don't care about. Oh, this thing we didn't even change. Okay, we definitely need to do that. Oh no, we did. We did relative vec here. But relative vec should take 0 and we should get 0 out at all times, right? Except for when we add on the origin. Oh, the scale there. Interesting. But it should still be 0. Because 0 times whatever should be 0. Let's just do one line at 0. Or maybe we'll do 2. So I'm going to say you get 2 lines here. 0 and 1. 2 lines here. Origin gets copied there. I is going to be 0 the first iteration. And then we go, okay. Let's do that. So we got our 2 lines. And when we go to the left, why do they get scaled twice as much basically? It seems like they're going... Yeah. So when I go 1, 2, 2 increments of my panning, it goes 1, 2, 3, 4, 5. It goes to 100 basically. I don't understand how that's even possible. So this just has to do with the origin getting mutated. Oh, because we copy from origin. We want to copy from a 0 vector. So start here will be a vector 2, and we'll have a x equal to that, and a y that is 0. I think that's what we want. Oops. Because we were scared. Yeah. We were scaling from the origin. Instead of saying our position is at 0, 0 relative to the origin, we said our position is some offset of the origin from the origin. So that makes sense that would be messed up. Okay, so that's that. And then here, I want to do the same thing here, but it's going to be start y is I instead of x. So put a 0 here, and then we'll delete the 0 there. And then we don't need this guy. And we don't need this period there. Alright. And then this can go back to being 1 bit shift over 9. Alright, so now our translation should work on the grid. There we go. And when we zoom, it is zooming, just the global zoom, and it looks like it's zooming fine. Great. Alright, so that bug is fixed. Let's go back over here. And this is not going to work, but I just want to see what effect it has so I can kind of think about it. So it kind of has the same effect whether I'm doing a relative or inverse relative vec. What I want to do is like puts this out, printf mouse mouse position, and then that'll be a tuple of %f new line. Sorry, my typing's like not great right now. Right. Get reoriented here. Okay, so it's going to be pos.x and pos.y. So this should be spewing out here as I move my mouse around. So I can kind of debug it. So here, if you go up here, it's like 0, 0, right? Basically. If I go up here, it should be 100, 100. Basically. Why is that 118? I need a smaller mouse pointer. In Hyperland Omarchi, how do I get a smaller mouse pointer? Yeah, that inverse is not working. Because as I zoom in, it should. Let's go ahead and not change that. And see if we can get at least a zoom going here. So if I zoom in here, this should be 100, 100 right here. It's close. It's like 120. Oh, because, all right, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. This should be 100, 100 right here. Yeah. And then if I restart here, mouse over that area, yep, about 100, 100. Okay, so the zoom is actually working correctly. We're getting the 100. So the inverse is working. That's good. So why then, when I translate, I guess I should manually do the translation here. So I'm going to translate over here. Now it's like 13. That doesn't make sense. Alright. Alright, so this is 100, 100. If I want to go... Wow, okay. It's now saying 200, 200. That's basically saying 0, 0. It seems like it should work, right? Oh, but we have to do subtraction first before the zoom to be truly inverse. My bad, my bad. That's probably what it is. So now, so this is going to be 100, 100. And then if I go like over here, that's just, yep, cool. All right, so now the inverse is working correctly. At least we have some solid primitive here to then see if this will work correctly. I don't think it will, but oh, that's not what I wanted. All right, let's try it. Not working now. Basically, this number should not change as I zoom in. And it is changing. So, it does not work. Before I dive into the code again, let me see if I can get a hint as to what is going on here. So, I'm just going to go slow. I'm at about 100, 100. So now I'm going 99, 99. So basically it's not, I'm moving up to the left. So it's sliding down to the right. I wonder if I started at the origin, or as close as I can get to the origin. Well, that one works. If I was down here, or say over here. Yeah, it's on a curve. You can see it like, okay. So you do have the right mouse position. Actually, I like having that in there. Let's see here. So the zoom factor, as we zoom in, we're updating the zoom factor. either increasing it or decreasing it by a tenth. Just don't quite understand the math required for this. It's basic linear algebra, but for some reason my brain's not like understanding. So I have both the coordinate in the absolute frame and I have the coordinate in the relative frame. So when I zoom in, what effectively am I doing? I'm applying a multiplication to every single vector. And if I want to zoom into a point, I want it to be relative to that point. I think it's just a plus and a minus. I don't think I need the zoom factor. All right, let's try that. Nope, definitely not that. No, I definitely need that zoom factor, because that scales it down significantly. Maybe I need to apply the zoom and not the zoom factor. Zoom. Nope. I feel like I need to draw to figure this out. So I'm going to get on the blackboard here. Good old blackboard. So yeah, I got a plane here. And I have a position, and I want to zoom into that position. So what does that mean? That means everything gets scaled out relative to this position. And if the origin is, say, here, it needs to get displaced out relative to this position. So say I'm zooming in 0.1 is the magnitude of the vector. Everything needs to scale out in all directions from that point 0.1. In the relative units, I think. Oh, this is tricky. So we have the vector going here. So we have to push out the origin vector by that zoom factor times the vector to that point. So we have the vector of the point. We apply the zoom factor to it. So I think we were going in the right direction originally, because we did have pretty good results originally anyways. I think this is the right idea. So we take that vector from the origin to that point, we change its magnitude by multiplying it by a zoom factor. So zoom factor is 0.1, it's a constant. So I effectively shorten the vector. And then here we're doing an addition of that vector if we're zooming in, or a subtraction of the vector if we're zooming out. Oh, sorry, inverse of that. So we add the vector because it's pointing in the wrong direction. We then need to negate it. So the operator is going to be negated. So in this situation, we're zooming out. On the top, this is zoom out. And then this is zoom in. If we're zooming out, the vector is pointed in the wrong direction. So normally zooming out, we would want to basically pull it in that direction, so we're going to add it. Yeah, so this math, surprisingly, this is pretty correct from what I can reason. And it's like generally in the right direction, but it's just like does not keep that consistent point. Oh, because the position doesn't change? No, the position changes as I zoom in. Yeah, every zoom element, yeah, it changes. So if I'm at 100, 100 here, I zoom in one time. I mean, it's pretty freaking close. Just a tiny bit of drift. I wonder if that drift is due to like imprecision and floating point. Maybe we multiply these numbers times 100 and see if we get more precision. I don't know, man. I think we got a lot of precision there. Let's open up a Python prompt here and just say, hey, what if I'm at 1 and I multiply it times 0.1? Because that's what I'm doing here. No, oh, this zoom is... Yeah, it's a difference because the zoom factor here... Huh. Yeah, that's the difference there. We need to do 1 minus the zoom factor. And then this, of course, needs to have higher precedence. So let's do that. I think this is actually the solution here. Of course, this is not very efficient, but maybe the compiler can eliminate that. This is going to be 1 plus the zoom factor. I think that might be it. Alright, let's try it. Nope. Nope. I would have thought that would have been the right thing to do there. One thing we could do is compute the delta between the two. So we have this new zoom factor, or new zoom value. We have the old position and the new position. That delta changes the vector that we need to apply to the origin to keep it in place. I think that's what we need to do. Yeah. Okay, so we're in here. We take our position here, and we're going to make it a relative vec. And we'll have our new pause. So we update our zoom. We do this computation to get our new position. Now the delta between these two is the delta we need to apply to the origin. So, well, I'll just do it in line here. We'll say, we could say new pause minus the old pause, in which case the vectors, so we're zooming out here. So I'm zooming out from a position. It's hard to visualize. So we're zooming out. Without modifying the origin, just doing a regular zoom out here. The vector is going to be closer to the origin. So that delta we have to add to the origin. So if we take the new and we subtract the old, I don't think that's it. If we take the old and subtract the new, it's actually new subtracted the old. Yeah. So new position subtract, has to be dot x component, subtract position dot x. And that'll be what we need to subtract here. New pause dot y minus pause dot y. Okay, so that's for that direction. I need a semicolon there. So we'll do the same thing here. But I think this is going to be a plus here. I think that's right. Let's try it. Zoom in, zoom out. Okay, now it's crazy. What if I just like slow down the execution to see what it's doing here? Maybe these are just inverted. I don't think that's the case, because I think that'll, yeah. Eh. Zooming in seems to work. So I want to zoom into the upper left of the red one. Kind of works. Let's try plus for both directions. Oops. How did plus... Wait a minute. If I'm only... Oh, so zooming in was right. Alright, let's get back to the place where we're zooming in is correct. Alright. So zooming in appears to be correct. Zooming out is crazy. So maybe it's a minus equals here. I'm really just relying on trial and error at this point. Alright, zooming in. Zooming out. Look at that. Look how beautiful that is. Okay, so it works as you would expect. Mostly. Starting to glitch out. Yeah, it did glitch out. I mean, I was working there for a hot minute. You see how the value stays the same? About 846 and 690. But then there's errors starting to creep in there at a certain zoom level. Yeah. That's the problem. The negative values throw it over as well. So it doesn't handle negative values well. I mean, in my head, I was just thinking about positive values. I wonder, does it mess up completely? I mean, at least we're on the right track here. It does work for positive values within a range here. Once you get to a certain scale out and it goes negative, that's when it stops working. All right, we're back to square one here. I mean, it works pretty smoothly if you're positive range and you're not at an extreme zoom level. The extreme zoom level thing might be because of precision. The negative values, I think we just need to handle those. If we go back here and I just translate over here and zoom in and zoom out, sorry. Okay. So we're at like, we'll put ourselves at like, what, 100, 100 negative? Okay, that's 100 there. And then about 100 there. All right. So I'm going to zoom out one tick. We went to 300, 300. Which would make sense if the new is being subtracting the old. So we have a negative 100 and then we have minus it's probably our translation's working correctly. Our inverse vector function's working correctly. Well, I'm at a bit of a loss here. Doesn't immediately seem obvious. But at least we figured out how to zoom in and out under certain circumstances on a single point. So you take the mouse position, you convert it into the coordinate plane that you're dealing with. Then you apply the zoom factor, the zoom to that. What's interesting, we applied the zoom and we applied the translation. I don't think I need the translation, do I? So this relative vec thing, I don't even know if that's the right thing to do because it's applying the zoom and the translate. I wonder if there's a bug in relative vec where with negative values, like the inverse seems to be working correctly. So I imagine the positive would work, right? Is scale and translate even the right order of operations? Yeah, I think this rec thing translate scale, scale translate, scale translate. Okay. That's probably right. All right. New pose. Well, let's just deal with zoom in. So we modify the zoom. We get the new position. What the hell? Modify the zoom, we get the new position. When you're in the negative zones, and say you just zoomed in, or you're negative to the origin, so zooming in is going to send you up to the upper left. That would add the value of the position, so it'd still be negative, and then you subtract that from the origin. I think that's correct. I mean, we could change this to a plus here and see if it like fixes the negative, but I think that's just gonna mess things up. I mean, it did go in the right direction. And I'm happy to call it here for the night. Sleep on it, because I am able to zoom in and out of positive coordinates in a semi-stable way. So who knew this would be like so difficult? I mean, once I thought about it, it kind of made sense to do what I'm doing currently. To get the mouse position, convert it into the coordinate plane, modify the zoom factor, then convert that coordinate into the absolute position, the new position. And that tells us how much to offset it. I'll have to think about this some more. But at least it works in certain bounded cases. You know, positive, and our scale isn't too extreme. Our scale or zoom out isn't too extreme. It works perfectly fine. So I think what I'll do here is I'll get the, oops, do I have jobs running here? No. Vim, source, draw, and I'll get the drawing of these things going again. Draw rect. Did I not do that? Oh yeah, I need to do that. Draw text, draw a line. We can just do relative vec on these, right? Relative rect. I do have relative rect. So I think I can just say relative rect here. And that's that. And don't even bother with that. Draw text. That's going to be this thing. And the text position, that's going to be relative vec of position. Oops. Something like that. Alright, let's try to get this thing back up and running. So we're going to draw a buff here, and it's going to be totally out of place because I haven't updated everything. Make, yeah. So just totally not on the grid at all. Okay. So let's try and fix that. So draw buff here. Size we'll just keep at 50. Margin 50. These are all fine. And then basically when we go to draw, we're going to say draw rect. Draw rect. This stuff I'm just going to comment out because I don't even know how to do that. I just want to get the rectangles going. Okay. Let's see if the rectangles are going to... Hey, look at that. Well, they work for a hot second. And then everything freaks out. So say I want to zoom into this thing, or this one over here. Let's not offset it from there either. So that would be up here. I think it'd just be size. Oh no, just margin. Offset is size plus margin. Yeah, that's correct. What is it that gives it the starting position? So we go in here. That's just boost stuff. X position here. I times offset plus X start and Y start. I think it's these two here. Yeah. So the X start get screen width divided by 2 minus layout width divided by 2. Layout width. What was this thing? It's only used here. It's the width of elements, so 64 times offset plus a margin. So that's the layout width. We divide that by 2. Okay, so I'm just gonna say margin here. And I'll fix that. Hey, look at that. Okay. Alright, I'm just gonna kill that. Huh. It's buggy. It is buggy. I think I'm directionally going in the right direction here. Getting everything into a coordinate plane and then scaling and translating that plane consistently across all the elements instead of doing all these manual calculations. I think this is the right direction for the code and for the project, but I have this bug that is with the scaling that is just like, I need to figure that out. It works really well on small values, kind of in this small range. But like you get out here, still working. Still seems to work out here, but like we got out further. Like we were like over here. Trying to zoom into here. It's just like, okay, that worked. But like, say I want to zoom in on this. You see how it threw everything all the way over there? So I think I need to do something where on every frame draw the vector to where I'm pointing at, and then the vector to where the origin, I know the vector to the origin. So I'm going to do some debug drawing of lines here. See if I can figure this thing out. Alright, I need to have this below. Where does update zoom? It only gets called in the loop down there, so I'm going to pull it down here. Okay. Update zoom. So let's draw a line. Draw a line, and the start vector is going to be 0, 0. So I can just say vector 2, and then the end is going to be position, and the color is going to be purple. So this should always point to where my mouse is pointing. I guess purple's not a color that I can draw. So it says purple's a color. Draw a line, start end color, right? Oh, I didn't pass the color here. Color. There we go. Okay. Okay. Alright, so the next step is to compute or to draw a line showing the new position. But that's already being drawn because it should be the same. So I'm going to do something like this. I'm going to say inverse relative vec here. Relative vec. So I pass it through a couple times. I could probably do this a couple times and see what the error is. So it might be just like accumulation of errors. And we'll just say test here. Test pause, and then we're going to draw our test pause. Why is this thing not? So you got 1, 2, 3, 4. Okay, I just didn't format it. Okay. And then instead of purple, let's do a different color. Maybe dark purple. All right. They look pretty much the same. I wouldn't be able to tell the difference. Let's bump up the line thickness. Can I do that? Draw V. Start end color. Okay, I have to do the EX where I give it the thick. Okay. EX instead of VEX, and then you give it a thick, and that's a float, right? Yeah. Oops. One. Where else is being used? Here. 10. 10. The frick? Okay. Yeah, I don't see any difference. The error is not in the conversion. Okay, so this new pause. Okay, I'm gonna delete all that. Let's do draw line direct. Direct. We don't do any of this. That'll allow me to debug some of these other things. So, all right. And do sleep 5 seconds. Man 3 sleep. Unix standard.h. Uni standard. Alright, I'm just gonna sleep between all this stuff here. Draw line direct. This start is just going to be vector. Can I do the end drawing thing here? Or is that gonna mess things up? Might have to do like end and then re-begin it. Like that. Oh, sorry. So this is zoom out. So this is going to be a draw line, not a draw line direct, from the origin to the new position, or to the position of the mouse. We'll have, sure, we'll do dark purple for that. And then we update the zoom factor. We compute a relative vec of the mouse position according to the new zoom factor to the new position. We then draw that as purple. Oh. This is not in the same coordinate space as this. I need to call this I position. And then this will just be position. This needs to be, yeah, like that. And then anywhere I'm using pause, here it needs to be iPause. Let's do that instead of doing all this debugging right now. See what that does, because I feel like that might help. Because I was assuming position was in the corner. Yeah, I think that's what it is. Yeah. Look, zoom, 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 zoom. Negatives still kind of snap, but we have a lot less glitchiness. No, there's kind of some glitchiness there. It feels better. But there is still glitchiness. And negative values, I can zoom out of negative values, but zooming into negative values, it does not like that. It snaps you over. All right, well, let's do some debugging around this. That's good. I did discover a bug there. Doesn't solve all of our problems though. Okay, so we draw a line from the origin to the mouse in dark purple. We draw a line directly from the 0 to the new position, and we want to do position as well. This is going to be like what? We have purple, dark purple, light purple, violet. We'll do violet. And then we do our subtraction. So here's where we're going to end our drawing. And then go into sleep for 20. We can do 10 here. I don't think I could go for 20. Yeah, we'll do 20, why not? Okay. Nope. Hey, look at that. It's kind of hard to debug. Oh, that's an interesting little factoid there. Look at that. Okay. So that's the one it's dark purple. We're drawing a line. Oh, but we want I pause. That's why, not pause. And I guess draw a line direct for pause. Okay. There we go. So I'm going to zoom in here maybe. So zooming in here, we would want the origin. How do we want the origin to move? It's got to go to the left. Because origin go to the left. No, it has to go to the right. Yeah, we want the origin to go to the right. And okay. I need to use different colors here because it's like a purple, blue here, a blue, and a red. So that's going to be the direct line to the new position and the old pause, which we don't really need anymore, right? We already have that here as purple. What we want to do is create a vector here, which is the subtraction of the two. We'll call it delta. Delta is equal to new pause auto delta minus equals delta dot x pause dot x, and then we'll do the same thing with y here, y pause dot y. So this is gonna be delta. We're gonna do as black because delta is like a black color, right? Delta, and this is direct. So this is the delta between the two vectors, and we can draw it twice here. So we can draw it off of the thing that we subtracted it off of, which was new pause, and then we can also draw it off of the origin. So that's what we're going to be subtracting it from. All right, let's try that. So that's what the origin was. That's the problem, is the blue lines there. Because if I, that blue line I think is the bug. So I zoom out here. Say I zoom here, that means that the origin needs to go to the upper left. Needs to move to the upper left. Let's just do one maybe here. This one would be like, it needs to move mostly to the left. Even that, I'm like, what? That blue line and the black line are just like crazy, man. And why is there like, bro, this stuff is like, let's do something simple. We'll eliminate the grid for now, because it's kind of like, sorry, the buffer, that's what I meant. All right. Let's reduce it just to be like 3 seconds, because otherwise it's like too long. Or let's just do 2 seconds. Okay, so I zoom out here, and then I zoom in. I'm at 100, 100. It's saying it would go all the way out there. I don't know about this, man. Let's move it over to here. Actually, let's restart it. Move it over here. And then I'm going to zoom in here. Why is it saying it way the hell over there? See, that's a bug right there. Like I take it to the right and I zoom in one tick on this 100 100. Oh, look at that. That's wrong. That should be 100 100 right there. Mouse position is 800 and 100. Oh, that's just my debugging log, right? Mouse pause and mouse eye pause, different between the two. This needs to be eye pause. Eye pause. Okay. Alright, so we send it over, oops, here. We're at 100 100, yep. So when I zoom in, it should scale out from here. We want the origin to be subtracted. Like that's a total bug there. So we gotta log this stuff here. I think I need a log and then I need to sleep longer here to be able to think about it. 60. Yeah, 10 minutes. Okay. So we need to get some logging going here. So this is gonna be new position. And I'll just fix these up here. Say new position X, new position Y. Oh, that's the bug. This needs to be eye pause here. Eye pause. Okay. Well, I'm going to continue adding logging here. So I updated eye pause here, but I didn't update eye pause here for some reason. All right. We have our draw line direct there. Our printf of our new pause. We compute our delta here, and then we draw a line from the origin is a direct line from the origin to delta. I don't think these are valid because you'd have to add delta to that. So let's delete those. And then we can add our print f here and say delta. Delta, what time is it? Oh, it's almost 8 here. Delta, delta. Alright, so zooming out, we got our stuff here, and I zoom in here. Boop. Okay. Seems reasonable. So let's take away the sleep, or maybe we'll just do 1 second. Oh, that's not good. Let's just not do all that. I mean, that seems to be working pretty good, right? I don't have any issues with that until we go negative, right? No glitchiness. It's pretty solid. I think that's the that's all of it. That's all of the bugs right there. Even with a negative. Yep. Just don't write bugs, man. That's the solution to all this. Alright, we don't need this delta anymore. That was just for debugging. Don't need that, it's for debugging. Don't need this, don't need this. So, what was the culprit here? So the first thing that I needed to have in place was the appropriate computation of where the origin should go. In order to get that, I needed to compute the delta between the current mouse position. So I had to get the mouse position, compute its delta between where it's currently at and where its new location will be after the zoom. So I would read the mouse position, I would convert it into an eye position that I could then later, using rel to vec, convert it back into a new position and then compute the delta. And then everything else was like bugs on top of that. Like it took me a little while to figure that out, granted, but then I had a lot of bugs where I was confusing pause and eye pause. I didn't have two separate variables for that. I was kind of conflating the two concepts. Where the position and the position in the coordinate system of the relative coordinate system. I call it an eye pause because it's the inverse relative vec of pause. But not having those as separate values meant that I was basically like converting between these two different coordinate planes completely erroneously. Two different coordinate systems, and I was using points from one as if there were points in another, which worked somewhat in some ways. What it did tell me is that my math was correct around here. This took me going to the whiteboard, to the blackboard here, and actually figuring it out using vectors. But once I had that figured out, getting clear distinctions between pause and eye pause, and then actually using them in both cases here. That was my problem, is that I had a freaking typo here. But now it seems to be working like legit. Like I can zoom in, zoom out. If it's negative, it doesn't seem glitchy. It just works. So that's what I was looking for. It shouldn't have taken me this long to do it, but it is what it is. Sometimes you just it takes a while to do things. So yeah. And then the directional arrows. Zoom, 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 zoom. Pretty cool. All right. So now I'm gonna disable doing all this stuff and just draw the buff. I'll leave the grid on for now. And then these lines that I was drawing to the origin and stuff in the mouse. I guess I deleted all that. I don't need that. Okay, shows up there. We can zoom out. I would like to click and drag and translate. That would be fun to do that. Yeah, let's do that. It's only 8. I did get zoom done today. Let's get rid of this debug grid. And then so click and zoom will have to register the mouse click. So I'm going to go to my cheat sheet. Click. Mouse. It's going to be a mouse button press. Mouse button down, mouse button released. So handle input will be the appropriate thing. If is mount button down, that's just a bool. Is being pressed, has been released once. So if it is being pressed, we're gonna need to so from the first time it's pressed, we have to record its coordinates, and then as it's being pressed and moved around, we need to update the origin, and then when it's released, we reset that. Okay. I'm going to do just some print lining here to make sure printf, actually I'll just do puts, released down, and too few arguments. Oh, the button, int button. I don't know a button I should give it. There's examples, so let's go to our examples. Core maybe? Mouse? Input keys, input mouse, there we go. Yeah, there we go. Pressed mouse button left. Oops. Okay. And then we'll say pressed. Is mouse button pressed? There we go. So let's go ahead and run that. And if I click, so it goes press, down, release. So really I just need pressed and released. The down I don't need to track. So if we're going into press, then we set into a mode where we're updating origin. Actually, update origin from pressed, record pressed position. I should say pressed position. Update origin for pressed position. Clear pressed position. We could do that. Okay, so here we're gonna need some global state here. We'll just say, hey, pressed position is going to be a vector 2. Because it's a global, it'll be 0 initialized. Here we're gonna say, okay, pressed position is equal to get mouse position. I think that gives you a vec2, right? Yeah. So that works. While the button is down, we're gonna say origin. We also have to record the initial origin. And it was pressed origin is equal to origin. Then here we're going to say origin is going to be plus equals to, or we have to get the current position. Since we're doing that in both of these blocks, let's go ahead and say auto mouse pause is equal to that. Mouse pause. Oops. Mouse pause. So minus, we have to do origin.x pressed origin.x. Wait a minute. No. That is not what I want. So we record the place where we started the click, and then and what the origin value was, so we can restore the origin. And then we move away from that. We need to compute the delta between pressed, not origin, but pressed pause. And that's going to be origin.x equal to pressed origin.x plus that. And then we do that for y. So this will kind of work, but I think there's going to be a bit of a glitch when we zoom as well while we have the mouse pressed. So you can do that. You can press and then you can zoom. And I'm not even like factoring that in at all. And then here we're just going to set the origin and clear everything. So now origin is equal to all of that. I don't think we need to do anything here. Yeah. Just comment that out for now. All right. Look at that. But zooming with that kind of glitches out. I mean, it kind of works. Like, it's glitchy, but I'm not gonna mess with it anymore. Okay, let's get the text back on, because that's something I did disable. And I'll just add a to-do here. To-do translating while zooming has a tiny glitch worth resolving. I'll just say it has a tiny glitch. We'll say here, fix glitch while minor glitch while when and zooming. There we go. All right, let's get the text back here. So this stuff is fine. No issues there. Measuring the text is gonna be kind of messy here. So I think what I need to do is I need to have in addition to draw text ex, I think this thing needs to do a measure. So I'll pull this out actually into the draw text thing. I'll handle that soon. This basically we take our X position plus size, box center. This is to get the center point. And then we subtract off the size. I don't think we need to do that. We'll just say center here. So it's going to be draw text center. And we're going to give it the center position, I guess. So it'd be here. And we don't need to give this a name. We can just do this as an inline. And just say, hey, you're going to be box center position. Oh no, I deleted those. Okay, we'll do it here. Draw text center. Definitely don't need that. Text, vector, and font size. This will just be a vector. Vector 2. Can I just do it? Yeah, I'll do auto. Or we'll say vector 2 text pause is equal to, and then here I'll just delete all that, convert those to commas, pass this in as text pause. There we go. And then I guess the color might be good, right? Float font size, color. Okay. Don't need that. Okay. I don't care. Okay. Let's go over to here and we'll figure this out now. So I won't do that quite yet because that's to get this centering going. But this get default font, we'll say, hey, text position will be relative to that. Our position we need to update. Font size is going to need to be updated as well. Relative font, I guess you'd say. Let's do that. We'll just say something here like a float relative font size. Float font size. Return font size times zoom. Okay. So this will be relative font size. And then this will be color. Okay, it's putting it at the position here. I like how well the zoom turned out. So now we just need to measure the size. So that's going to be width. That would be text size. And the position. So position is equal to that. Font size as well. Okay. Put the font size back here. Font size. Now, and the font we can just pull from here. Font is equal to that. Auto. And this could be font. Font. All right. Sorry, auto. Okay, so measure text EX font text. Font size. Okay, spacing. Spacing is what, a float? Yeah. Okay, so now we need to update the position. Position dot x is equal to, or minus equals to, half of the width, which would be something like text size dot x divided by 2. Yeah. Okay, that gets it relatively centered. And then I wanted to add some stuff to the top. I think we should have some spacing though, on this font at least. Spacing 1, and then y plus 1. I think the problem with doing the plus 1 there is that it's not going to be consistent. Like if I zoom out, it's going to be, doesn't even show up. Maybe like 5. Oh, I'm doing plus. Yeah, that's why. Do you do minus 1? Oops. Oh, escape works too. Okay. done for the evening. I'm gonna record a little update for my accountability pod. But yeah, pretty happy with the result. Go ahead and get this committed and pushed. But yeah, pretty happy with the result. Progress today. I had 2 stretch goals. I wanted to get the addresses showing up on the left-hand side, and I also wanted to have the memory addresses. Like, I need to have some type of header for the maps that allows me to understand where in the page of memory, the bytes are starting. So I'll work on that this week, but yeah, pretty happy with the progress here. So I'm gonna hop off, and I guess tomorrow I may or may not stream. Depends on if I have time. But yeah, excited to make some more progress on this week. Cool.